This is section 3.3, long division of polynomials, and the best way to understand long division of polynomials is to understand and revisit long division of regular numbers, right? So let's say we have 157,598 divided by 21. Saying that you don't have a calculator, you don't start thinking how many times will 21 fit into 157,598. What we do is set up the division problem, and there's our division problem set up. The 157,598 is inside the box and the 21's on the outside. So we don't think how many times will 21 go into this huge number. We think about it, how many times will 21 go into 157? And even easier, we think how many times will 2 go into 15, right? Without going over. So how many times will 2 go into 15? 7 times. And I know that I'm not really doing 2 and 15. I'm doing the 157, but I'm just guided by the 2 and the 15. So the 7, I'm actually going to write it up here on top of the 7. And in a sense, what I end up doing is kind of like distributing. 7 times 1 is 7. 7 times 2 is 14. And what do I need to do from there? Subtract. So I'm going to put a subtraction sign right there. Now check this out. For future reference, I want to do something weird that we did not do in 4th grade. I want to put parentheses around the 147. Why? Because we're going to have to do that today when we do long division of polynomials. So 157 divided by 157 minus 147. When we work that out, we get 0. 7 take away 7 is 0. 5 take away 4 is 1. And we end up with a 10 right there. And what do we do from there? Bring down the 5, right? So we're going to take that 5, bring it down, so we're going to have 105. And again, you could think 21, how many times will go into 105? But the easier way is to just think of the 2 and think of 10. 2 and 10. 2 times what gives me 10? 5. And in this case, it works out nice because when you put a 5 right there, 5 times 1 is 5. And 5 times 2 is 10. So when we subtract right there, and again, for the sake of what we're doing today, we're going to put parentheses around that. 105, take away 105 is 0. Cancels out completely. What do we do next? Bring down the 9, right? Okay. And will 21 fit into 9? No. So what am I going to put up there? A 0. And all that does is moves me on to the next number 8. And the 8 will come down, and we end up with a 98. And 21 going into 98, again, the easier way of thinking about it is to just think of the 2 going into 9. 2 going into 9, how many times? 4, okay. So if we go 4, it'll be a 4 right here. And if you distribute, that'll be an 8 right there. So 8 take away 4 is 4. And 9 take away 8 is 1. And we have what we call a remainder. You guys remember that? Yeah, so you don't want to put a R14 like we did in 4th grade or 5th grade, right? We used to put a R14 like this, R14. What the heck is that really? Okay, that's unacceptable in high school. So what we're going to do is just erase that. And what we need to do is write it as a fraction. Whatever's left over, you have to put it over the original divisor. So you're going to put that 14 right here, but you're going to put it over the original divisor, 21. Okay? Now, if you're thinking, what the heck? It really becomes a lot easier when you check out, So that remainder, it's a little bit more clear if we take a look at something really easy, kind of like, what's half of $3? $1.50, right? Everybody knows that 3 divided by 2 is 1.5. But if you were to think about it in this long division format, 2 times 1 gives you 2. You subtract, you'll have a remainder of 1. And again, that remainder goes over the original divisor. So the remainder is 1. You put it up there. And it's over the original divisor, 2. And that's why it's 1.5. Make sense? So the remainders, we're always going to put over the original divisor. That way we end up with fractions. Anyhow, what we're going to do now is compare this regular division problem with the division of polynomials problem right here. Okay? So everybody please copy that down. The first thing to recognize is that the cubic trinomial goes inside the box. The linear binomial goes outside the box. So the y minus 3 goes outside of the division box. Now inside, you want to write your polynomial, but you want to write it in standard form. And here's another very important part. You want to write it representing every single power. So standard form, you want your highest exponent term first. That's going to be a 2y to the third. So 2y to the third is the first term. Minus y squared is your second term. Is there a y? No. So I need to represent that y even though it's not there. How am I going to do that? I want to put a plus 0y even though it's not there. And I'm also going to put that plus 25 at the very end. So ladies and gentlemen, there is my division problem. Now what we're going to do here is almost treat it like this one where we focused in on the 2, not the whole number and not the whole number 21, but just focused in on the 2 and the 15. That's what we're going to do over here with this guy. We're going to focus in on the first terms. So here's y. Y times what gives you the first term, 2y to the third? 2y squared, right? And you want to put that 2y squared, you want to stay organized. We know it's 2y squared, and notice that I lined it up right on top of the other y squared. You want to be totally organized. Y squares on top of y squares, y's on top of y's, and numbers on top of numbers, all right? That's going to be the setup. So anyway, kind of like where over here, when I found out that 2 times what gave me 15, I said 7. I kind of distributed 7 times 1 gives me 7. 7 times 2 gives me 14. We're going to do the same exact thing over here. We focused in on the y, and we're going to have to distribute. So 2y squared times negative 3. What's 2y squared times negative 3? It's negative 6y squared. And notice that I wrote it right below the minus y squared. And let me distribute 2y squared times y. What do I get? 2y to the third. That was the whole purpose of multiplying this y times 2y squared to get the same exact value, 2y to the third. You guys with me? Now, what did we do over here? We subtracted. And that's why I put it in parentheses, because over here we're going to have to subtract, but we're going to put it in parentheses. So check it out. I'm going to subtract, but I'm going to put it in parentheses. If you forget to put the parentheses, you will mess up on this, guys, because the parentheses reminds you that the minus sign gets distributed to both terms of the binomial. So what do I end up with? I end up with a negative 2y to the third and a positive 6y squared. So let me put a negative. After I put it there, it's a negative, and I put it over here, it's going to be a positive 6y squared. So when I look at 2y to the third minus 2y to the third, it cancels out. When I look at minus y squared plus 6y squared, what do I get? 5y squared. That's right, 5y squared. Okay? And then what do? I bring down the 0y. Okay? And that is a plus 0y. And once again, I'm going to go to my first term only, not the whole binomial, but just the first term. Y times what will get you that 5y squared? Y times what? Y times what will get you that 5y squared? Help me out, guys. 5y. And that would be a positive 5y. And notice that I wrote it right on top of these y's. Everything's organized. Y squares, y's, and then numbers, right? So now that I know that y times 5y gives me the 5y squared, now I could actually distribute it to both terms, get a binomial down here, and then subtract it. So I'm going to distribute it. 5y times negative 3 is negative 15y. And then 5y times y is going to give me the 5y squared. And don't forget that we are subtracting, and because it's a binomial, we have to put that minus sign with parentheses around the binomial. Are you guys with me? Yeah. So what does that do? It changes the signs. This is going to become a negative 5y squared. This is going to become a positive 15y. So, of course, the 5y and the minus 5y cancel out. And over here, we end up with a positive 15y. What do we do next? Bring down the 25, right? Plus 25. And once again, you don't focus in on the whole binomial. You just focus in on the first term y and the first term 15y. Y times what will give us the 15y? Times 15. So I'm going to put a plus 15 up here. And when I distribute correctly, that'll be 15 times negative 3. That's negative 45. And then 15 times y, that's 15y. And of course, we are subtracting, so we're going to put in parentheses with the minus sign on the outside. And when we distribute that minus sign, that's going to become a negative 15y, which cancels out. This is going to become a positive 45. So we end up with 70. That is your remainder. So what do we do when we have a remainder? We put it over the original divisor. So what I'm going to do is go back up here and put a plus sign, and I'm going to put a fraction, and we said the remainder goes on top, and the original divisor, y minus 3, goes on the bottom. Ladies and gentlemen, this is your answer for that division of polynomials up there. And this is also on a PowerPoint that's also on Edmodo. So if you didn't understand this video too well, maybe you want to click through that PowerPoint, it'll help you out.